Hi, this is the video for page 30. Okay, so let's get started. We learned in class on example 1 that if we can see a pattern between each number, then we can continue that pattern, and this time they'd like me to continue it for the next 3 steps. So we need a number, and then another number, and then another number. Okay? So there's a handful of ways to do this, but let's kind of look, is it going up or down? It looks like it's going down. So we're thinking subtract, they're subtracting or dividing. Hopefully that kind of makes sense. We also notice they could be adding by a fraction, or multiplying by a fraction. So an example of that would have been, let's say I took the number 5, and if I multiplied by 3/4 or 0.75, see how that would make the number go down. So if I multiplied by 0.75, the number goes down. So you could go down by multiplying by a fraction less than 1. Okay, so those are some ideas. Well, let's try the easy way. Let's just maybe probably subtract. So figure out, did something subtract there? So let's take a look. Looks like they subtracted 12, so minus 12. And then if I took 89 minus 12, I get 77. Minus 12 again, 65. So I'm feeling pretty good about this pattern that each time they're subtracting 12. I've confirmed that each time that is exactly what happened. So I'm just going to continue that pattern and come up with my answer. Minus another 12, minus another 12. Beautiful. Now let's look at the next example. We notice the numbers going down again, but we also see a fraction coming. So this kind of reminds me of the example we did in class. I'm thinking they divided by something. So I could figure that out. 9 divided by 3 would give me 3. So it's not like they divided by 3. So I'm going to do 9 divided by 6 to figure out 1.5. Okay. Or 6 divided by 9, I get 0.6 repeating. So if I took 6 divided by 9, I get 0.6 repeating. So it looks like maybe they did this multiplying by a fraction. This is a fraction, this repeating decimal. You can use it as a decimal, but it is the fraction 2/3. I can prove it to you. Let's see. Let's double check. 2 divided by 3. Yep, 0.6 repeating. So it looks like because I did 6 divided by 9, I got 0.6 repeating. 4 divided by 6, let's try that out. 4 divided by 6, I also got 0.6 repeating. 8/3 divided by 4, I get 0.6 repeating. So it looks as if each time they're multiplying by 2/3, which is the same thing as dividing by 3, but then also multiplying by 2. So it's kind of a combination. It feels like we're multiplying by a fraction. You could say we're dividing because you're dividing by 3, but then you're also multiplying by 2. Okay, so let's continue this pattern. And again, I want to make sure everybody understands this. If I multiply by 2/3, make doubly sure that this is the pattern you're seeing. 9 times 2 divided by 3 is 6. You could also do it 9 times 0.666666, and you see how you get a number that's approaching 6. All right. Now let's continue the pattern. 6 times 2 divided by 3 I get 4. Feeling pretty good. So I keep going. I'm going to multiply by 2 and divide by 3. Multiply by 2, divide by 3. I get 2.6 repeating, which is the same as 2 2/3, which is the same as 8/3. See, 3 times 2 is 6, 7, 8. 8/3. So I'm going to keep going. Here it is in my calculator. I got to continue it for 2 more patterns. So that would be times 2/3. So times 2, divide by 3, 1.7 repeating. Do it again. Times 2, divide by 3. Ooh, 1.185 repeating. Got to do it one more time. Times 2, divide by 3. I don't see a pattern. 1, 2, well, it's kind of 1, 2, 3, 4, 5. It's kind of a cool pattern. Okay, so I'll just put 0.79. So I would take these. I probably also would take some other interesting fractions that should be fairly close to or equivalent to these fractions. If you wanted to keep them as fractions, notice you could say 8/3 times 2/3 would equal 16/9. I could double check my work. 16 divided by 9, yep, is 1.7 repeating. Okay, I could keep it as a fraction. Once again, I'm going to multiply by 2/3. I get 32 on the top. And 9 times 3 is 27. I could verify that that is in fact this decimal. 32 divided by 27. Yep, same thing. So again, both of these would be correct. Either one or both, good stuff. Last time, I'm going to multiply by 2/3. So my numerator is 64, and my denominator is 81. So 64 over 81 should be close to this decimal. Let's try it out. 64 over 81. Perfect. Loving it. Now let's see if we observed a pattern here. And I feel like this is similar to what we did in class. So let's take a look. Observe the pattern made by these figures. Can you write a conjecture? So that means what comes next. I believe I know what comes next. You write a conjecture about the number of triangles formed by connecting one vertex of a polygon within. So I know what comes next and comes next and comes next. Okay. So, first off, I notice there's 3 points, so that's something to notice. So the number 3 matches the number of points. This number matches the number of points. This number matches the number of points. We also call that vertexes. This number matches the number of points, or vertexes. So you could have said 3 points, 3 vertexes, or 3 sides. Maybe you notice, hey, this object has 3 sides. This object has 4 exterior sides, 5 exterior sides, 6 exterior sides. Any of those would be something to notice. All right. Now let's see, what did they do with this line? So it looks like if I take a point and I extend it to the adjacent vertex, I get the outside. Here, if I extend it to the adjacent one, it looks like they came up with, we have a term for this in math, we call that a diagonal. Now I don't have a diagonal here because if I go from one side to the vertex, one side to a vertex, I don't go through the shape. So it looks like here I see no diagonals. One diagonal. Hopefully you're seeing this pattern, 2 diagonals. 3 diagonals. So I think we can, and there's another pattern buried in here. It's awesome. And these just repeat. So 3 points, 4 points, 5 points, 6 points, 3 vertexes. This has 4 vertexes, 5 vertexes, 6 vertexes. This has 3 sides, 4 sides, 5 sides, 6 sides. So we know what comes next. Here, I think we know what comes next. Here's something else you could have noticed based on our activity. So there's so many things you could have noticed, and any or all of them would be great. So that these are our diagonals. These were our vertices, right? These were our sides. If you notice the sides, that's what you noticed. Now, you could have also noticed the unique spaces. That's something else you could have noticed, unique spaces. So this created only 1 space, 2 spaces, 1, 2, right? 1, 2, 3 unique spaces, 1, 2, 3, 4 unique spaces. So unique spaces, I have 1, 2, 3, 4. I think we see the pattern. It's continuing there. So again, it's saying, can you write a conjecture about the number of triangles formed by connecting the sides? So they're actually trying to get us to figure out number of triangles. So these unique spaces, notice all these unique spaces are 3-dimensional. Pretty cool. Check out the next video to see how we finish question 12 and the rest of the questions.